Here's an example of two congruent triangles. As you can see, AB is congruent to ED, its corresponding side. Same as angle CAB and angle FED are congruent. This is just like the definition of congruent triangles. This video will go on to demonstrate an activity to use to prove the congruence of triangles. For this activity, you'll need 6 pieces of pipe cleaner. Each pair of pipe cleaner will need to be the same length. It is also helpful to have each pair represent a different color so you can understand the difference between the corresponding sides. You will also need 3 pieces of foam to represent the angles of the triangle. Here's the given triangle we will be proving congruence for. Now we are going to prove side, side, side. This means we are given 3 sides that we know are congruent to the given triangle. We are going to see if we can put together these 3 sides to come up with a triangle that is congruent to the given one. By moving these closer, we are trying to put together to make sure the angles are equal also. As you can see, when we put the sides together, we are given a triangle that is congruent to the other ones. No matter where we place the sides, we are still given a triangle that is congruent to the given triangle. It may be reflected, but is still the same and congruent triangle. Now we're going to go on to prove angle, side, angle. This means we are given 2 angles with a side in between. We are going to see if given these 3 things, if we can come up with a triangle that is congruent to the given one. We have extended 2 lines to represent the missing sides. As you can see, they intersect at one point. We have gone ahead and laid out the sides that we know are the same length, and as you can see, they are the same length of the congruent triangle. Therefore, angle, side, angle does prove congruence of triangles. Next, we are going to prove side, angle, side. This means we are given 2 sides with an angle in between. We're going to go ahead and let you decide if this proves congruence or not. Hopefully you found that side, angle, side does prove congruence of triangles. Now we are going to go prove angle, angle, side. This means we are given 2 angles and a side, but the side only intersects one of these angles. We have gone ahead and extended missing sides. As you can see, the given side is not touching the base of the triangle. So we will go ahead and try to move it closer until it touches the base of the triangle. Now that the side is touching the base of the triangle, we put the congruent sides next to it to see if they measure the same of the given triangle. As you can see, they do. Therefore, angle, side, angle does prove congruence of triangles. Now we are going to see if side, side, angle proves congruence of triangles. This means we are given 2 sides with the angle only intersecting one of these sides. From this picture, it looks like side, side, angle does prove congruence of triangles. However, since the red side is not set by an angle, it can move, forming another triangle. And as you can see from this picture, the base is not the same length of the blue side. Therefore, side, side, angle does not prove the congruence of triangles. Now we are going to go on to prove angle, angle, angle. This means we are given only 3 angles. The length of the sides are unknown. From this picture, it looks like angle, angle, angle does prove congruence. However, since the sides are not set in length, we can actually extend these angles out, providing a bigger triangle with the same angles. And that's the end of the activity. Hopefully now you understand the evidence needed in order to prove the congruence of triangles.